Okay, hello guys, welcome to this video. I was just checking out the Advent of Cyber event and some of the prices and the requirements or some things that I would do that would not allow me to get a reward. I understand it's sharing, that I can still share these videos even if they contain the answers, as long as they're in videos and streams, right? I understand that if it's a blog post, then it's not allowed. All right, so the day 6, if I can't find a nice malware to use, I'm not going, okay? Major malware was scheming quite full of delight to ruin SOC mass and frighten SOC teams, but Glitch and MaxKite had spoiled his plan by uncovering secrets that exposed the demand, okay? Major Malware slammed his hand on the table, his eyes narrowing as the report flashed on his screen. Legion Waxkite had uncovered his trail. He took a deep breath, calming himself. No matter, he muttered, a sinister grin forming. They may have found me but haven't stopped me. His confidence steamed from the malware he had crafted, so devious and advanced that it would easily evade detection. But before unleashing it to wreak havoc on SOC teams and ruin SOC mass, there was one final step. He needed to test it in a sandbox. So, learning objectives. Analyze malware behavior using sandbox tools, explore how to use YARA rules to detect malicious patterns, learn about various malware evasion techniques, implement an evasion technique to bypass YARA rule detection. Okay? Connecting to the machine. Let's start the machine already. Am I giving credentials to connect directly? Yes, I am. I already started it. If the VM is not visible, yeah, okay, so these are just the credentials. RDP, I think when it's a Windows machine, I would rather just use the attack box here. So okay. At the bottom of the page, alternatively, you can connect out to the VM via remote desktop using these credentials. He slipped this malware into the sandbox to see what tricks he could play and what flaws there might be. For sandboxes, you see, are used by the wise, defenders inspect, but attackers revise. Okay? Detecting sandboxes. A sandbox is an isolated environment where malicious code is executed without affecting anything outside the system. Often multiple tools are installed to monitor, record, and analyze the code's behavior. Major malware knows that before his malware executes, it needs to check if it's running in a sandbox environment. If it is, then it should not continue. If it is, then it should not continue with its malicious activity. Okay, to do so, he has settled on one technique, which checks if the directory program files is present by querying the registry path. The value can be confirmed by visiting the registry path within the registry editor as shown below. Okay. To open the Windows registry editor, navigate to the Start menu. On the bottom, select Run, enter regedit, and press Enter. This directory is often absent on sandboxes or other virtualized environments, which could indicate that the malware is running in the sandbox. Here's what it looks like in the C programming language. Constructor, registry path, okay, current version, value name, program files there. Prepare the command string for rage.x. Churn command, sprint size of command, rage query, rage path. Okay, run the command, declare an integer. It's gonna be the result. If result is 0, registry query executed successfully. Otherwise, failed to execute registry query, and then this is the main function construct. This is the flag redacted registry check. Then you call this function that we just implemented. Yeah. And then you return 0. Don't worry, you don't have to understand every detail of the code. All you need to know is that this function is designed to check the system's registry for a specified directory path, program files there. This path's presence or absence helps the malware determine whether it's running in a typical or virtualized environment like a sandbox. So can YARA do it? Major Malware knows that MaxKite is a big fan of YARA rules. YARA is a tool used to identify and classify malware based on patterns in its code. By writing custom rules, analysts can define specific characteristics to look for, such as particular strings, file headers, or behaviors, and YARA will scan files or processes to find matches, making it invaluable for detecting malicious code. And Major Malware does not think such a simple tool can detect his malware, but just to be sure, he has to test it out himself. To do this, he wrote a small script that executes a YARA detection rule every time a new event is added to the system monitor log. This particular YARA rule detects any command that tries to access the registry. Let's have a look at the rule. Rule sandbox detected meta description detects the sandbox by querying the registry key for the program path. Author TryHackMe date version string cmd. A command. Software Microsoft Windows. Current version, the program files there, condition CMD. Okay, let's understand the contents. In the string section, we have defined variables that include the value to look out for, which is at CMD, right? In the condition section, which is here, we defined when the rule will match the scan file. In this case, if any of the specified strings are present. Okay, for its testing, Major Malware has set up one function script that runs a YARA rule and logs true positive in ctools YARA matches.txt. Open up a PowerShell window, navigate to the ctools directory, and use the following command to start up EDR. It's not even loading. What's going on? All right. Given that it's not here. Ooh. Okay. I'm sorry. Let's check this out. So RDP. Yeah. So what is the server? The server is this particular IP. RDP should be good. Then the administrator is the username. Username administrator, the password. Then we already have the domain, blah blah blah. Save and connect. What up? What up? What up? What up? Yes, sure. Are we connecting? Looks like we are. Yeah, okay, finally. Okay, so on to the task. They told us to open up PowerShell window. Yeah, sure. So let's open PowerShell as an administrator. Then you want me to navigate to the ctools. Yeah, sure. Okay, I'm already here. What do you want me to do here? I use the following command to start up the EDR. Jingle bell, jingle bell, jingle bell. Okay, starting. And we get some errors. No events were found that match the specified selection criteria. Get when logged in. Okay. You know what? There was a way for me to do a dynamic resolution update. Yeah, that's the one. Okay. So what's going on? I'm getting no events found. System log. Yeah, no new events found. And then monitoring system press. This tool will run on the system and continuously monitor the generated event logs. It will alert you if it finds any activity event that indicates the registry mentioned above key is being queried. Now run the malware by navigating to ctools malware. Okay. We go to malware and double click on Merry Christmas. Meaning just execute it, right? Which I just did. If our customer's created its job, you should have witness a pop-up by our EDR with a flag included as shown below. This will include the answer to question 1. Well, no, looks like it didn't work because I wasn't prompted for any flag. Did you get the same error I did? Jingle bells of PS1. So what if I execute that again? Oh no. Wait. Jingle bell, jingle bell, jingle bells. No events found. No new events found. I'm running this again, right? Just to see if it might detect something that the malware has executed on that particular path. It looks like nothing. No events were found that match the specified selection criteria. It's jingle bells, right? YARA matches jingle bells.ps1. Yeah. Tools. Yeah. Let's understand the contents. Oh yeah, I think it's because I haven't completed the first part. right? Detecting as long as it's an isolated environment, your malware notice malware executes, needs to check if it's running on a sandbox environment. Yes, only one thing it checks if the directory C program files is present by querying the registry path here. The value can be confirmed within the registry path. Okay, so let's no evidence were found. Okay, so let's just do what they did. Start menu and then click run. Run. Yes. No. Reject it. Yes. Okay. Now, where do we want to go? We want to go to Windows current version, right? It's HKey local machine. Yeah, and then software. And then Microsoft. And then Windows. Just Windows. And then current version. Program files there. The value can be confirmed by visiting the registry path as shown below to open. Yeah, okay. This directory is often absent in sandboxes or other virtualized environments, which could indicate that the malware is running in the sandbox. Program files there. It is often absent in sandboxes or other which could indicate that the malware is running in the sandbox. Here's what it looks like in the C programming language. Don't worry, you don't have to understand. All you need to know is that this function is designed to check the system's registry for a specified directory path, which is program files there. This one, right? Okay. Can Jira do it? Let's have a look at the rule. He wrote a small script, right? That executes YARA, listens to the contents. We already understood the contents. For his testing, Mayor was to set up a one function script that runs YARA rule and logs a true positive. In C tools, YARA matches. Open up PowerShell window, navigate to the C tools. Yeah, already did. And use the following command to start up EDR. This tool will run on the system and continuously monitor the generated events logs. The thing is that I'm getting an error. Right, get win event exception, non matching events found. Get win event. No events were found that match the selection criteria. Get win log name word object. Okay. Cat. This is the PowerShell script. And to be honest, I shouldn't have to modify anything, right? Just run it. And then jingle bells.ph1. But then I get no events were found. Is that the same error? That matched this jingle bell. Yeah, I mean, they also get that error. A YARA result, and then it gets a YARA result. Monitoring system events. Press Ctrl C to exit. Okay, that's good. So it's already running, right? Monitoring system events. That's what we got. So looks like it's monitoring right now. Double clicking where no, run the malware by navigating to C tools. Okay, let's go. Let's not use PowerShell to execute that malware. Let's go to C, then tools. Where's that? Here. Tools, then malware. Then let's double click on Merry Christmas.exe. And now I should get a prompt with this flag, right? Given that this is monitoring. And then the YARA rule must jump out and tell me what up. Press Ctrl C to exit. I don't want to exit. YARA result. Okay. Malicious detected. Okay, let's fill out the question number 1, which is this flag, right? Which is the flag displayed in a pop-up window after the EDR detects the malware. It's THM, and then glitch was here, right? All right, let's move on. We executed that. If our instance termination, why? See, I don't like what this happening. I don't like that one bit. I don't get why it happens. It happens to me quite often. Large screen recommended this side anyway. What? Okay, vendor assessment progress. What do you mean? You'll be assessing 3 vendors based on their responses to security questions. For each vendor, review the vendor's responses. I just want to continue with the box. What is going on? Vendor risk assessment. No, I just want to start the machine, the box again. What is this? Let's minimize this. All right, so it's starting again. Adding more evasion techniques. No, okay, yeah. We executed the BX, we got a flag. For a custom script that is job, you should have witnessed a pop-up by our EDR with a flag included. As shown below, this will be the answer to question 1 below. You can now exit the custom EDR by pressing Ctrl+C. Okay. If the pop-up does not show, however, the PowerShell item in the taskbar, it should show the pop-up that was generated. Okay. Adding more evasion techniques. It seems that YARA can detect the evasion that your malware has added. Don't worry, because we can make our malware even stealthier by introducing obfuscation. This is the C code, registry code, const chart. Voila. Okay, prepare the PowerShell execution command, share command, 512, printf command, and then PowerShell encoded command, yeah. Result system, check for successful execution. Okay, code explanation. The above code does the same thing. Query the same registry key to get the information about the program data. The only difference is that the query is now encoded using base64, and the code uses the PowerShell to execute the query. The encoded string can be checked by decoding it using a tool like CyberChef, as shown below, which translates to the path. Okay, be aware of flaws. While obfuscation is helpful, we also need to know that there are tools available that extract obfuscated strings from malware binaries. One such tool is Flush, a powerful tool developed by Mandiant that functions similarly to the Linux string tools, but it's optimized for malware analysis, making it ideal for revealing any concealed details. To try out Flush, open a PowerShell window and enter the following command: X, and then you're executing this Merry Christmas, and then the out file is going to be tools small strings. The above command can take up 2 minutes to complete. In the meantime, let's break down the command. Okay. +X, this command scans for strings in the binary Merry Christmas.x. If any hard-coded variables were defined in the malware, Flaws should find them. Wait for response. Come on. Please respond. The pipe symbol redirects the output of the command in front of it to the input of the command behind it. It redirects the output of the command in front of it to the input of the command behind it. Okay, I see you. Out file C tools mouseString. We save the command's results in a file called mousestrings. Once the command is done, open mousestrings.txt, press Ctrl F, and search for the string Mayor malware. Enter the flag as the answer to question 2. The format of the string is THM. Okay, so let's do that. Let's open PowerShell, run as administrator. Now what we want to run here is tools plus then plus X tools malware Merry Christmas.x. Yes, pipe out file tools mousestrings.txt. Okay, they did say that this could take a couple minutes, so I guess we're gonna have to wait a bit. But then, once the command is done, open the mousestrings.txt, which is, so let's go through this. It's in tools, right? Tools, and then mousestrings.txt, and then what? Open the press Ctrl F and search for the string Mayor malware. Okay, hasn't finished yet. Search for the string Mayor malware. Enter the flag as the answer to the question number 2. The format of the string is THM. All right. Do we have it? Not yet. Okay, let's keep reading because we're just gonna retrieve that flag after we make a search with Control F for Mayor malware, and then we should get the flag, right? Once this command is finished. So let's keep reading. Using YARA rules on system logs. These YARA rules are becoming a pain to Mayor malware's backside. If he wants his malware to be undetectable, he needs to research how YARA rules can be used to stop him. For example, his research tells him that YARA rules can also be used to check system logs for any artifacts left by malware. He'll need to test this as well. Sysmon, a tool from Microsoft's internal suite, continuously monitors and logs system activity across reboots. This Windows service provides detailed event data on process creation, network connections, and file changes, valuable insights when tracing malware behavior. Yeah, a YARA rule will look for events with event ID 1 process created for this to work. There are many what? Entries in the Sysmon log. To make it easier to find the event we're looking for, we will apply a custom filter using the event record ID that we can see in the log YARA matches.txt located in ctools. Open a PowerShell window and enter the following command to check the contents of the EDR log file. Alrighty. Get content ctools YARA matches. Okay. Let's make sure that this is running. You should get a similar result similar to the output below. Note down that the event record ID value will use this value to create a custom filter in this Windows event viewer. Next, open the Windows event viewer by clicking its logo in the taskbar, and on the left-hand side, navigate to the application and services log. Microsoft Windows is more operational. Continue by navigating to filter current log. On the right-hand side of the screen, you should see a window like the one below. Okay. What is it that I am waiting here? Like, okay, so I should be able to actually access this. Mayor malware. Cannot find him. Who's that boy? Mayor malware. Find next. Okay. Mayor malware. What's going on? Yeah, here it is. Something here. Hidden clue. DHM hidden clue. Maybe that's the one. Second question. What is the flag found in the malicious text after running floss X? Opening the file and text editor. Hidden clue. That's the one. Okay. There was no Mayor malware, however. Okay. Be aware of flaws. We already did that. So using YARA rules on system logs. Okay. Let's read this again, okay? Because my brain was still thinking on what we were doing before. So the YARA rules are becoming a pain to Mayor malware's backside. If he wants malware to be undetectable, he needs to research how YARA rules can be used to stop him. For example, his research tells him that YARA rules can also be used to check Sysmon logs for any artifacts left by malware. Okay, he'll need to test this as well. Sysmon is a tool from Microsoft's internal suite, continuously monitors and logs system activity across reboots. This Windows service provides detailed event data and process creation, network connections, and file changes, valuable insights when tracing malware behavior. A YARA rule will look for events with event ID 1 process created. For this to work, there are many entries in the system log. To make it easier to find the event we're looking for, we will apply a custom filter using the event record ID, okay, that we can see in the log YARA matches.txt located in ctools. Open a PowerShell window and enter the following command to check the contents of the EDR log file. So, get content, ctools, YARA matches.txt. Okay, we got nothing. You should get a result similar to the output below, which I didn't. YARA matches tools, YARA matches.txt. What's going on? Get content. Get content, C tools, YARA matches.txt. I'm getting nothing. YARA matches.txt. Is this an empty file? This is an empty file. Do you want me to add anything here? YARA will look for events with event. Yeah, sure. No, I don't. No doubt that the event record ID value will use this value to create a custom filter in the Windows event viewer. Next, open the Windows event viewer by clicking on its logo. in the taskbar, but I didn't get anything like that. Okay. Note down the event record ID, which is what, this one here. Okay, we will use this value to create a custom filter in the Windows Event Viewer. Okay, just open up the Windows Event Viewer by clicking its logo in the taskbar. In the left-hand side, navigate to Applications and Services Log. Windows Event Viewer, where's that? Windows Event View Event Logs, is that it? Windows Event Viewer, okay. Now by clicking on this logo in the taskbar and on the left hand side, navigate to Applications and Service Logs, Microsoft. Let's see, no Microsoft. Microsoft Windows is non-operational. Okay. Microsoft Windows sysmon. Let's go to sysmon operational. Okay. Continue by navigating to filter current log. No, where's that? Filter current log. What? Create custom. Continue by navigating to filter current log. View. Create custom. Yeah, create custom view. No, filter current log. Where's that? Continue by navigating to filter current log. Operational. Help. View. Create custom view. Import custom view. No. Open safe log. No. Right click properties. No. Do you want to start a service? No. Cancel. Maybe one of these items. File. Action. View. Filter current log. Oh, I had to click here. Okay. Filter current log. Anytime, yeah, you should see a window like the one below. Yes, I do see it. Navigate to XML and tick the checkbox. Tick the checkbox, edit query manually. Okay, click yes to confirm. Finally, copy the following filter into the input box. Okay, I guess I have to replace all this. Copy. Unable to paste. Why am I not surprised? There was a feature here that would allow me to copy and paste. Don't tell me it's not here when I need it. Alright. I just want to copy this, come on. Okay, let's not waste any more time. Query list. Query list. Yeah. After that, there's that. No. There's 2 spaces, I guess. Well, maybe 4. Yeah, 4 spaces. Query ID 0 path Microsoft Windows sysmon rational. Then we close. Go to the next. 4 more. Select path Microsoft Windows sysmon operational. And then select, close it, and then system event record ID, insert event record ID here. Yeah. Okay, we're done. Replace the event record ID value with the one you recorded before. So event I'll replace the event record ID value. Insert the event record ID here. Apply the filter by clicking OK. So the one we recorded is supposed to be this one, because when we run the PowerShell get content of this, we got nothing. So I guess we might as well just use the one that they used. So let's just replace all this with number you got, 9596517. This, okay. Apply the filter by clicking OK. Now you get the event related to the malware. Click on the event, and then on the details tab, you should get the following output. Okay, replace your event record ID value, yeah, with the one you recorded before. Apply the filter by clicking OK. Now you get the event locator specified as invalid. What if I remove this? What now? Yeah, that's what I thought. Okay, let's assume it's valid, and then we're able to see something like this. Details, yeah. Parent process ID. You should get the following output. Yeah, let's take a look at the event data that is valuable to us. The parent image key shows us which parent process spawned the cmd.x process to execute the registry check. We can see it was our malware located in ctools malware, Merry Christmas.x. The parent process ID and process ID keys are valuable for follow-up research. We could also use them to check other logs for related events. Yeah, the user key can help us determine which privileges were used to run the cmd.x command. The malware could have created a hidden account and used that to run commands. The command line key shows which command was run in detail, helping us identify the malware's actions. The UTC time key is essential for creating a time frame for the malware's operation. This time frame can help you focus your threat hunting efforts. Never gonna give up. His malware, it seemed, it wasn't quite ready for town. There are watchers and scanners and rules by the ton. If I'm not careful, they'll catch all my fun. Mayor Malware leaned back, tapping his fingers thoughtfully on the table. All of this research have revealed an unsettling truth. His malware, as cunning as it was, wasn't yet ready for the wild. There were too many tools and too many vigilant eyes. Analysts armed with YARA rules, sysmons, and a host of detection techniques that could expose his creation before it even had a chance to spread. So he clenched his fist, a determined glint in his eye. Just a little more fine-tuning, he murmured. He would study, adapt, and evolve his malware until it was truly undetectable. When the time was right, he would unleash it upon the unsuspecting SOC teams, striking when they least expected. But for now, he would wait, watching, planning, and he was perfecting his craft in the shadows. Okay, yeah, sure. If you want more about Sandboxes. Okay, that's everything for the day number 6, guys. I'll see you on day 7.